Now, in our next lesson, we will introduce LEDs. Before we do that, a little bit about file management. In Tinkercad, you might not want to keep overwriting the same circuit with new additions, so if you would like to create a copy of this one, you can click on the Tinkercad logo in the upper left to go back to your account and see all of your circuits. Hover over one circuit, click the gear icon, and then click Duplicate to create a copy. You can see it will automatically name it with copy in the file name, but again, you can change that to whatever you want. In this case, I'll call it lesson 2 LEDs. You can add LEDs to the circuit the same way you added the Arduino and the breadboard by clicking and dragging from the circuit components list on the right. Once the LED is in the circuit area, you will get a pop-up window where you can rename it and change the color. You can also rotate it using the rotate button in the upper right. So again, this is a matter of personal preference in terms of how you connect it to the breadboard. The LEDs are designed such that the two leads are spaced to fit into two adjacent rows on the breadboard. But if you wanted to connect it across the gap in the middle of the breadboard, like I would typically do if I was doing this in the lab, you can set the LED and then use wires to connect each of its leads to the breadboard. And again, for color coding consistency, I'm going to make those gray so they kind of look like they're just the extended leads of the LED. Two different ways to connect it to the breadboard. Both of these are valid. It's a matter of personal preference. What you should be careful not to do is to put an LED in like this, where both of the leads are in the same row. Again, I'm assuming you do know how to use a breadboard at this point, but just a reminder, if you do that, these two leads will be shorted together and the LED will not light up. Now, once I have the LEDs in the breadboard, I can use wires to connect the anode or positive side with the longer lead to my power bus and the cathode or the negative side with the shorter lead to my ground bus. Again, for consistency, I'm going to change those wire colors. And once I do that, I can hit Start Simulation, and it will simulate the circuit. And you can see that Tinkercad will simulate blowing up the LED, just like in the real world. If you forget to include a current limiting resistor, you'll get too much current through the LED, and the LED will burn out. So I'm going to stop the simulation, and I need to add a resistor in series with the LED. Again, we're not covering basic circuit analysis in these tutorials, so if you don't know Ohm's law or how to calculate the current limiting resistor value for an LED, there is a separate video linked in the description on how to do that. Here, I'm just going to click and drag out the resistor, just like I did for the other components. Again, depending on the breadboard orientation you've chosen, you may need to rotate the resistor. When you get it close enough, it should snap into the breadboard holes. So I'm going to delete this wire and add a wire down here. When you select the resistor, you will get a pop-up to change the resistance value. The default is 1 kiloohm. Again, we're just eyeballing this and not doing the calculation for now. I'm going to change that to 330 ohms because 1 kiloohm is a little high. When I run the simulation, it will then show this LED lighting up. Finally, remember that LEDs have polarity. I have wired this one backwards and gotten the cathode and anode reversed. Tinkercad will account for that in the simulation. So when I run this simulation, you see this LED will light up and this one will not. So now you have your next assignment. Wire a circuit with 3 LEDs that are all different colors, run the simulation, and make sure they all light up.